are doing lab experiment number 7. It's about verification of Thevenin's theorem. So here we have the table 1, where we have been asked to measure the resistances, the 4 resistances. So here I picked up the 4 resistances. I will measure the resistance for each one. Here is the 1 kilo ohm resistance. I put this one on ohms. I check that I'm connecting the common and the ohm. So here I measure the resistance. It's almost 1 kilo ohm resistance, so it's 0.992. Then I go to the other resistances, 2.2 and the 3.3. Here is the 500 ohms, so I connect it in this way. And it comes to be 0.572 kilo ohm, which is 572 ohms. And here we have 500 ohm, so we write here 572 ohms. After checking all the resistances, we go to table 2 and we connect the circuits, and we measure the current that is flowing through the load resistance. The load resistance is 500 ohm, so we measure the current here. So how we can connect the circuits? We have 12 volt source. So we have, here is the 3.3, here is the 500, and here we have the 2.2 and the 1. So this is the circuit as shown here. Now we can connect them together. So here I have this circuit as here. So I need to connect the ammeter between these two resistances, the load resistance and the R3. So here's I have the ammeter connected between the common and the milliampere. I connect here at milliampere, and the AC is off. It's okay. So now it's almost 0. So I will bring this here. I will connect between R3 and the load resistance. So here is the positive, here is the negative. So from here I will adjust this one to 12. It's 12 volts, and here I have the current 2.9 or milliamp. Ignore the minus sign. If you want to change the minus sign, just change. Maybe because I connected here the negative, so I have to disconnect this one. Connect it here, positive and negative. Now I have it in positive, so I will write down here the milliamp. Here I will compute it using these two formulas. Now I have to find the voltage across R3 and write it down here, which is V Thevenin. So I will disconnect this one, disconnect the load resistance. Now to measure the voltage across R3. So So I will change this into voltage. So I will connect here the positive, and here I will connect the negative. So we have 6.5 volts, and I will write it down here. Now to measure it using this formula, you will find Thevenin. Now the third part is to short the circuit from this supply side to measure Thevenin using the DMM. So here's the circuit. I will short it from here. I'll put here an ohm. So now it gives me this 1.6, or let's say 1.8 or 9 kilovolts. Let me put it correct. It's 1.6 kilo ohm. So I will write it down here, and I will compute it using this rule. Finally, I will connect the potentiometer in series with an ammeter in series with the R load with Thevenin. So I will disconnect this circuit. Potentiometer, which is variable resistance, I connect the positive or the negative here, and the other terminal is connected here, not here. So if I connected this one here, it will give me 10 kilo ohm, but I connected right here at the short end. So at the short end with this side, I can vary the voltage from here. So I want to make this one equal to Thevenin. So I will change it to 1.62 kilo ohm. So here is my Thevenin. So I adjusted this to equal to Thevenin. Then I have this R load. I will disconnect this one. I will connect this one here. Now I need to put the ammeter between these two actually. So what I'm going to do is I will connect the same circuit here. So I will put the ammeter here. My circuit, I connected the positive of the ammeter here and the negative here. And here is my source connected to the short end, and here, and I will adjust this to equal to Thevenin. So I make it 6 volts for example, and then this is my ammeter. So here it's connected, we have the Thevenin voltage is adjusted, and we have the Thevenin resistance adjusted, connected in series with the R load. So the current is 3.25 milliamp approximately, or it can be less than that. So we will write it down here. We compute it using Ohm's law here. So now we have finished lab number 7. Thank you.